Hello, this is the part 5 of the video series on coordinate geometry. So in this video, we'll be looking at parallel and perpendicular lines. So what do I mean by parallel lines? When two lines are parallel, they have the same gradient, basically. And how do we show this? In maths, when you see two lines carrying arrows in the same direction, it means that those two lines are parallel. For example, you have this, and you have them carrying arrows in the same direction. So if this is line 1 and this is line 2, if these two lines are carrying arrows in the same direction, it means that they are parallel. So if this line has a gradient of m1, and this one has a gradient of m2, so the gradients must be equal. So that's the condition for two lines to be parallel. Two lines are said to be parallel if they have the same gradients. So the parallel if they have the same gradient. So M1 is equal to M2, parallel lines. Okay, so you can see this even without anyone telling you that the slope, these two lines have equal slope. The only difference is that this is drawn above this one. So if I translate this line, if I move it upward slightly, this line, if they are parallel, should fall exactly on that line. Okay, so that's what we mean by parallel. So they can never meet. They continue to extend and they meet at infinity, as we used to say. Okay. So what about perpendicular lines? So we've seen the condition for two lines to be parallel, that M1 must be equal to M2. So the gradient of line 1 must be equal to the gradient of line 2. So what about perpendicular? Perpendicular lines. So what's the condition for two lines to be perpendicular? So if we have, let's say we have two lines and one is perpendicular to the other. So if this is line 1 and this is line 2, these two lines are perpendicular if they meet at right angle. Okay, so they are said to be orthogonal. So that's another way I can refer to them. They are said to be orthogonal to each other. Okay, so what is the condition for these two lines to be perpendicular? So if this line has a gradient of M1 and this line has a gradient of M2, it means that the product of the gradients M1, M2 must be equal to -1. So that's the condition for the two lines to be perpendicular. So two lines are said to be perpendicular if the product of their gradients is equal to -1. So that's the condition. Okay. So very important, take note of that. This for parallel lines and this for perpendicular lines. That's the condition. Okay. So let's look at some examples. Example 1. So let's say you have, the question is, find the equation of a line that passes through 2, -1 and parallel to the line 2x plus 3y minus 5 equals 0. So how do we deal with this? Now we have the equation of the line that's the line in question, the line we want to find passes through. So what we can get from this equation that we're given is the gradient. So we're able to get the gradient of this line. It means that the gradient of the line we are looking for must be the same as the gradient of this line because they are parallel. So that's the condition. So what I need to do now is to get the gradient of this line and then make that gradient equal to the gradient of the line I'm looking for. So how do I get the gradient of this line? I need to write it in the general form of y equals mx plus c. So if I can write it in this form, then I know that the coefficient of x will be the gradient. So what I need to do is just to make y the subject of the formula. So let's do that. 2x plus 3y minus 5 equals 0. So how do I make y the subject? I move 2x and 5 to the other side. So 3y will be minus 2x plus 5. So if I divide both sides by 3, so y will be minus 2x plus 5 all over 3. So which I can write as minus 2x over 3 plus 5 over 3. I can split that. So clearly I can see the gradient coming out because that is the coefficient. If I compare it with this general form of the equation. So I know that m, which is m for the line I know, I can call that m1 for line 1 that I know, is equal to minus 2 over 3. Then I can use this to get the gradient of the second line that I'm looking for. So because they are parallel, I know that m1 will be equal to m2, parallel lines. So the line 2 that I want to write its equation will have a gradient of minus 2 over 3 as well. So now I know the gradient of that line, and I know a point the line passes through. I should be able to write the equation. So if I use the equation y equals mx plus c, so I know that m for that line 2 is minus 2 over 3, so I can replace that here. So y will be minus 2 over 3 x plus c. So how do I get c? I know m, I need to calculate c. If I substitute this coordinate in this equation, so anywhere I see y, I put minus 1, and x, I put 2, I should be able to calculate c. Okay, so y equals minus 2 over 3x plus c. Y equals minus 2 over 3x plus c. And the coordinate I have is 2 minus 1. So minus 1 will be, I have 2 minus 1. So y is minus 1, x is 2 plus c. So minus 1 will be minus 4 over 3 plus c. Then minus 1 plus 4 over 3 will be equal to c. Then it means that if I make this to have the same denominator, I'll have minus 3 over 3 plus 4 over 3. So minus 3 plus 4 will give us 1 over 3. So it means that c will be 1 over 3. So therefore, the equation of the line y will be minus 2 over 3 x plus 1 over 3. So by line, I can write that as minus 2x plus 1 all over 3. By cross multiply, 3y equals minus 2x plus 1. And I can write it as 3y plus 2x minus 1 equals 0. So in the third form, this is the equation in the third form. Remember that form, ax plus by plus c equals 0. So that's the third form I'm talking about. So here, a is 2, b is 3, and c is minus 1. Okay, so this is the equation of the line. This is the equation of the line that is parallel to this line and passes through this point. Okay, now let's look at another example. Example 2. So find the equation of the perpendicular bisector of the line joining 6,2 and 4,6. So that's the question. Now to find the equation of the line that bisects the line that passes through these 2 points. So let's say the line that we know is this. Let's just assume is that line, and I know the coordinate of 2 points that the line passes through. So this is not correct representation of the line. I just want to assume that these are the 2 points, so point 1 and point 2, 6,2. So the perpendicular bisector will pass through here. What do we mean by bisector? A line that is perpendicular to that line and passes through the middle of the line. So if this line is a bisector of this line, so if this is line 1 and this is line 2, if line 2 bisects line 1, it means that line 2 must intersect line 1 at the middle. So basically at the midpoint of this line. Remember, we've done midpoint. I can use midpoint formula to obtain these coordinates, xm, ym. So which is the coordinate of the point that this line passes through. So once I get that coordinate, then what I need to do next is to determine the gradient of this line. That's easy because I can determine the gradient of this line. And if I use the relationship between 2 perpendicular lines, I can figure out the gradient of this line. Okay, so the first thing I will do is to determine the coordinate of the midpoint where this bisector passes through. So how do I get that? Xm, ym, remember the formula will be equal to x1 plus x2 over 2 and y1 plus y2 over 2. So that will be equal to, so if this is 0.2 and this is 0.1, then my x2 will be 6 and my x1 will be 4. So I will have 4 plus 6 over 2, and I will have 6 plus 2 over 2. So that will give me 10 over 2, and this will give me 8 over 2, so which is 5, 4. So that's the coordinates of the points that bisector passes through. So I know this point now. So the only thing I need to get to be able to write the equation of this line is the gradient of this line. So I can get that gradient if I know the gradient of this other line. So I need to calculate the gradient of the other line, m1, which is the gradient of the line that I know. That's y2 minus y1 over x2 minus x1 is y1. And that will be, so what is y2? Y2 will be 2 minus what is y1? 6. And what is x2? 6. And what is x1? 4. So y2 minus y1, x2 minus x1. And that will give you minus 4 over 6 minus 4, that's 2. And that will give you minus 2. So the gradient of the first line is minus 2. So I can use that relationship to figure out the gradient of the second one. So what is the relationship? Recall that the product of the 2 gradients must be equal to minus 1. It means that m2 will be minus 1 over m1. So m2 will be minus 1 over m1 is minus 2, if I remember correctly. Yeah, minus 2. So this minus cancels this minus. It means that m2 will be half. Now I know the gradient of the second line, and I know the coordinate of the line it passes through, which is the coordinate of the midpoint, 5, 4. I can write the equation. So it passes through 5, 4, and it has a gradient of half. So I can write the equation. So y equals mx plus c. Now let me use the second method. I've not used that before. Y minus y1 over x minus x1 equals m. If you remember this equation, that's the second form. So I have one point, which is which is this coordinate. This will be y1 and this will be x1 in this case, and this is m. So if I replace this and this, I'll have y minus 4 over x minus 5 equals half. So if I cross multiply, y minus 4, 2 equals x minus 5, okay? So this will give me 2y minus 8 equals x minus 5. So 2y minus x minus 8 plus 5 will be equal to 0. So 2y minus x minus 3 will be equal to 0. So that's the equation of the line. Okay. Then I will do one more question, and that will be it for the video. So let's look at another example. Example 3. So the question is, line A has equation 7y equals 3x minus 4, and line B has equation 3y equals 5 minus 7x. Because the question is, show that line A is perpendicular to line B. So what do? I just need to find a gradient of each one and check if I get if the product of the two gradients will be -1. That's all I want to do. So I need to find the gradient of this, multiply them, and check if I get -1. Okay, so for the first line, 7y equals, this is line A, equals 3x minus 4. Then y will be 3x minus 4 all over 7. It means that y will be 3x over 7 minus 4 over 7. It means that the gradient of that line will be 3 over 7. So the coefficient of x. Now for line B, I will have 3y equals 5 minus 7x. So 3y equals, I can rearrange this as 7x plus 5. So by divide both sides by 3, then y will be minus 7x over 3 plus 5 over 3. So the gradient for this will be minus 7 over 3. So what I want to do now is to multiply the two of them and see if I get -1. So m1, m2 should be equal to -1. So what is m1? 3 over 7 times what is m2? Minus 7 over 3. Should be -1. Is that the case? Yeah. 3 can cancel 3, 7 can cancel. And so 1, 1, 1, 1. So it means that -1, there is a minus here, equals -1. So which is what you want to prove. Okay, we stop there, and I'll see you in the next video.